So for number 9, I'm going to write the reference points. Negative 1. 1 over b would be 1/5. And then 0, 1. And then 1b, which is 5. Okay, so now we plot the points. Negative 1, 1/5. So we're just, again, approximating 1/5. It's really hard to show with this pen, but oops, sorry. So that would be about here. 0, 1, and 1, 5. Okay, so it's really steep, like that. And then they also want you to state the asymptote, the intercepts, and state whether it's increasing or decreasing. Well, this one's obviously increasing. The base is 5, right? You don't even have to graph it. You just look at the equation. The intercept is 0, 1. The asymptote is y equals 0. So number 11, I'm going to switch over, make it a positive exponent. So again, to make it positive exponent, I take the reciprocal of 5. So this becomes 1/5 to the x. Okay, and then the reciprocal, negative 1, comma 1 over b would be 5. Then 0, 1, and then 1, 1/5. So we plot the points, negative 1, 5, 0, 1, and 1, 1/5. Connect the points. Okay, so this is increasing. I'm sorry, take it back. This is decreasing. The intercept is 0, 1, and the the horizontal asymptote is y equals 0. So for 13, the reciprocal of 5/4, because for negative 1 it's 1 over b, is 4 over 5, 0, 1, and then 1b, which is 5 over 4. So negative 1, 4/5, so that's about here. 0, 1, and 1, 5/4 is 1 and 1/4, so that's about here. So it's a really flat, exponential function. Okay, so this one is increasing. I'll put it up here. It's increasing. The intercept is 0, 1, and the horizontal asymptote is y equals 0. Now for 15, I'm going to treat the negative a little bit differently than I did with number 11, just to show you an alternative way. So the negative is in front of the x, so that means that the x's are going to be multiplied by negative 1. So negative times x, negative 1 times x. So the transformed points would be 1, 4/5, 0, 1, and negative 1. Oops, let's see. I wrote this one wrong. Sorry, this should be 5/4. Didn't make sense. Hold on. 5/4, because this is just the base 1b. And so when I write this, it's negative 1, 5/4. Okay, so I'm going to graph it now. So then I'm going to plot the pink points, because those are the transformed points. So it's 1, 4/5, so it's 1.8. So about here. Let me change the color. About here. 0, 1, and then negative 1, 5/4, which is 1 and 1/4 about here. So it's coming in like this. So it's also steep, except it's decreasing. Okay, so this one's decreasing. The intercept is 0, 1, and the horizontal asymptote is y equals 0. So I want you to notice what happened with 11 and 15. On 11, I converted the exponent to positive first, so the 5 became 1/5. And then I treated it like a straight out decreasing function, right, with a base of 1/5. But on 15, I kept the 5/4 and I used the transformation of, the b when it's in front of the x. It affects the x right here. And so I just switched these points, which turns out to be the same at the end of the day, but I just wanted you guys to see two different ways of approaching the problem with a negative exponent. Alright, so 17 is an exponential function of growth with, showing growth and moving to the right 2 units. So if you look at the 4 graphs for A, B, C, D, the ones that show growth are B, C, and D. And then moving to the right 2 units would be D. So for number 17, the letter is D. Okay? And then 19, it's moving down 4 units. So it's the same growth function, but it's moving down 4 units. So again, between B and C, the one that's moving down 4 units would be C. So for number 21, you have to describe how to get g of x from f of x. So the bases are the same, so the only difference is that g of x is translated to the right 5 units, and that's what you would write. G of x is translated to the right of f of x by 5 units. So the points, that means we would add 5 to all the x's. So -1 plus 5 would be 4. So this point would be 4 1/3, about here. And then 0 plus 5 would be 5, 5 1. And then 5 plus 1 is 6, so 6 3. Okay, so the graph would be over here, shifted to the right 5 units, and that would be g of x. Alright, for number 23, you have the plus 5, which means that the graph of f of x is translated 5 units up. So the points, the y values are increased by 5. So instead of -1 1/6, it's going to be -1 5 1/6. So -1 5 1/6, again, that's about there. Instead of 0 1, it's going to be 0 5 plus 1 6, 0 6. Instead of 1 6, it's going to be 1 11. So 8 9 10 11 right there. And so let me just go ahead and draw it. The asymptote also moves up 5 units, so just go ahead and graph that and then connect the points. So that would be g of x. So for 25, g of x is a reflection over the x-axis of f of x, and then it moves to the left 4 units. Okay, so it translates to the left 4 and reflects over the x-axis. So I put right above the reference points right here, x minus 4 for the reflection, for the translation to the left, and -y for the reflection over the x-axis. So then the points become -1 minus 4, -5, -5 thirds, and then 0 minus 4, -1, and then 1 minus 4 is -3, -3 fifths. So these are the points that we're going to graph. Well, the black points and the pink points on the same graph. Alright, so here you see f of x, 3/5 to the x power, and so that's a decay function because 3/5 is between 0 and 1. Okay, so now we're going to graph -5, -5 thirds, so that's -5, -1 and 2/3, -4, -1, and -3, -3 fifths, so that'd be about here. And so it goes this way. So it shifted to the left 4 and then reflected over the x-axis. Alright, so for 27, g of x is translated to the right 2 units and down 3. Now the b is 0.4, 4/10, right? So I converted it to a fraction of 4 over 10 and then reduced it to 2 over 5. So 0.4 is the same as 2/5. So right here, the reciprocal of 2/5 is 5/2, and then b is 2/5. So I just kept it as a fraction. You could write it as a decimal, but either way is fine. So here I put the transformations, and so now I'm going to do the new points. So -1 plus 2 is 1, and then 2.5, 5/2 is 2.5. So 2.5 minus 3 is -1/2. 2 plus 0 is 2. 1 minus 3 is -2. And then 2 plus 1 is 3. And then 2/5 minus 3 is -2 and 3/5. Okay, so those are the points we're going to graph. Alright, so the blue graph is f of x, so the point forward to the x. And so now I'm going to plot g of x with the new form, the new points, the transform points. So 1, -1/2, 2, -2, and 3, -2 and 3/5. -2, 3, -2 and 3/5 would be about here. So the asymptote went down 3, so I'm going to just go ahead and draw it right there. And then the graph goes like that. So that's g of x. Okay, so in number 29, g of x is a reflection over the y-axis. That's what the negative in front of the x means. And then plus 2 means that it's going to be translating up. It's going to be moving up. So the opposite of x would be 1, and then 4 plus 2 is 6. The opposite of 0, well, that's just 0. 1 plus 2 is 3. The opposite of 1 is -1, and then 2 plus 1/4 is 2 1/4. Alright, so for 29, like I said, it's reflected. I kept the negative in the, instead of switching over the base to 4 and keeping the x positive, I just kept it as they wrote it down for you guys, and took the negative as a reflection over the y-axis. Okay, so you can do either way, either thing. So I'm going to plot 1, 6, 0, 3, and -1, 2, and 1/4. So that's about here, and then the that horizontal asymptote goes on y equals 2, and it's something like this. So it now looks like a growth function, okay, and it's translated up 2 units. Alright, so number 37, I went ahead and did the reference points. Remember, -1 goes with 1 over b, so that's a reciprocal of b, which is 2/5. 0, 1, and then 1, b. The base is 5/2. And on the graph, I just skipped every tick mark to label it as a 1 unit, so every tick mark is a half a unit. So -1, 2/5, so that's a little bit under half. So -1 about here, and then 0, 1, and then 1, 2.5. So that would be about here. Connect the points, and there's your graph. They want to see, identify any asymptotes. So this would be y equals 0. Alright, so 39, the base is 6. So -1 goes with 1 over b, which is 1/6, the 0, 1, and then 1/6. So -1, 1/6, 0, 1, and 1/6. And so with that, connect the points, and it goes like this. The horizontal asymptote is y equals 0. Alright, so for f of x, for number 41, the x plus 2, that means that the graph is going to be translated to the left 2 units. So the x's are going to change, so -1 minus 2 is -3, but the y's stay the same. -2, 1, and 1 minus 2, -1, 3. So plot our points, -3, 1/3, -2, 1, -1, 3, and it goes something like this. The horizontal asymptote is y equals 0.